Hello everyone, this is Imtiaz Alam, and today we'll be discussing about design a web crawler, and this is one of the topics discussed in the book on system design interview that you see on the left. Okay, what we'll see is what are the use cases for the web crawler. So we have too many use cases, but these are like the common one. Search engine indexing, basically where you think a site like Bing, Google, Yahoo, or other search engine basically goes to any website and crawls and collects all the information and indexes it to give you the search results. Web archiving is another use case. It is basically meant to back up the entire website to prevent from cyber attack or to recover from the cyber attack. Web analytics, this one basically you can think of where you want to monitor the change content, and this is also used for, let's say, fetching the competitor page for price analysis. So let's say you and your competitor is selling the same product. You could have like a spider that goes through the competitor website and fetches the price of each and every item, and then you can do a comparison for your own website. I'm not sure whether it's legal or not, but this is one of the use for competitor purpose. And then web monitoring. Web monitoring is a very good use case. It's about monitoring your web page availability. Imagine you have a website and your website have links and every some of the sub pages also have links, and you want to ensure that all of your links are working. So let's say if you have 5,000 links, it's very hard for you to go and click on each and every link and ensuring that's working. You could write a spider, basically a crawler that can go and monitor all the each and every web page, maybe runs every night and give you the report of any page that doesn't exist. This last one here is basically OWASP Z attack spider. This is basically used for penetration testing. So you write a spider, it tries to penetrate or try to visit all the page and sub pages on your website and see all the pages that it can access. So it could be possible that you have some page that is meant for only authorized and authenticated user, but using the crawler you can find out whether it is working that way, or you can go to any website which you're not supposed to go. So basically you can create those kind of reports. Okay, next we will look at the design scope for this crawler. So what's the design scope? You have been given a set of URL, and taking a URL, you want to go through a web page, extract all the URLs, and then you want to add those URL into the queue so that you can process, right? And here you could do like a DFS, kind of depth first traversal, or a BFS. So depth first traversal will be, let's say, on your home page you have 5 links. You pick the link one and then you visit, and then you go and get other link from that sub page, and likewise you continue going in depth. And breadth first is basically you are going through all the links in the first page and then you are going to the second page. And as you are visiting, you are also putting these links into the queue. Okay. Next thing, before jumping into any design, you should be always asking clarifying question, whether you're doing it for the real life or you're doing it for the interview purpose. So you need to understand why we are doing it. What is the end result, right? Why we are building this. Once you know that, this is basically any problem, say design a web crawler or design a Google Drive, you want to know why we are doing this. Even though you understand what web crawler is and what Google Drive is, you want to understand the scope and the purpose. Okay, and then you need to be asking like how many web page to crawl, and this will basically you can come to a conclusion the scalability requirement, because you need to understand the workload, right? Extensibility, and what it means is, in this particular case, what kind of contents we need. Do we need to include link, images, PDFs, other documents, or we are only looking for just link? So clarify that, because this will give us the processing time and storage estimate, right? So we need to know. So if we are just getting a list of URLs, but we don't want images or PDF or any other document, then we will have less storage requirement. So it's very important to understand this. Then, of course, this is very important how often we need to crawl. So politeness. So imagine if you have a crawler or a spider that's kind of making a 20 requests per second or even 20 requests per minute. It's very impolite because you are taking away the resources that is meant to be used by a real customer. So you don't want to overwhelm and make too many requests. Otherwise, it will look like you are making a denial of service attack, and the page can block you, right? Freshness. So definitely, whenever you are visiting a website, so sometimes the content doesn't changes very often. So you want to see like how if there is a changes. Do you want to worry about the new changes, or you just want to you don't care about if the status has changed or not? You just want to make a copy every time you visit. You just make a copy. You don't care about duplicate. So basically, you need to think about that. And then definitely storage requirement. Do you want to store it for 1 week, 1 day, 1 month, 1 year, or 10 years, right? That will you need to get that estimate. And then how to deal with the duplicate or bad content, right? Uh, let's go back. Next slide. So next is we look at the back of the envelope estimation. Here, basically, the idea is uh, when we say back of the envelope, that means it doesn't have to be accurate. You can round up and you can just say roughly. So everything we kind of say, it's a kind of a hand wavy number. We say, okay, let's say we have to crawl 1 billion pages per month. Let's say 1 billion pages per month, and we have 100,000 seconds in a day, and then if we are doing for 30 days, so roughly we are visiting 350 pages per second across the internet, right? And let's assume average page size is 500 kilobyte. And if you think about the storage, since we are visiting 1 billion web page every month, and each page is 500 kilobyte, that means we need to have 500 terabyte of storage per month. And if you take that 500 terabyte storage per month, and if it is for 12 months and we are storing for 5 years, that means we need 30 petabyte of storage, right? So just come up with some numbers, and and again, these are not accurate. These are just estimate and all are rounded up. For example, in 1 day we have only 86,400 seconds, but I rounded up to 100,000 seconds, right? And that's fine. Second thing is we need to look at the different components for the web crawler. So there are 7 different components shown here. We'll go through each of these components on the subsequent pages. So the first one that we are looking at is a seed URL. Seed URL is basically, you can think of the entry point of the URL. So let's say if you want to crawl the entire Microsoft domain, so your seed URL could be www.microsoft.com. So that's the entry point. And from there, you want to crawl all the rest of the pages. So one thing you need to know is like almost every website, the well-behaved website, we're going to have a robots.txt file in the root folder. So if you go to www.microsoft.com/robots.txt, you will get a text file. And this text file contains the instructions for the robots or bot or spider to instruction like what they are allowed to do, what they are not allowed to do. So we will see one example in the next few slides. Basically, it contains 4 things. One, it talks about the user agent that are allowed, a list of allowed web pages, list of web page that is not allowed, they're saying the robot or the crawler is prohibited, they should not go to those pages. And then also they will also contain a sitemap. Sitemap basically contains a map of the entire site. So when the robot sees the sitemap, it's very helpful for them because they can just go to sitemap and they have everything there instead of going and crawling and trying to figure out everything on their own. Okay, so this is the seed URL. Next, we'll see the URL frontier. And URL frontier is basically a queue, and this queue contains a list of URLs that needs to be processed. Now, again, this is a priority queue, right? So as we understand, the queue is simple, is first in, first out. Priority queue is a queue where some other item that's getting added could go into the first of the queue or anywhere in between the queue. Okay. So, and why it is important? For example, let's say, uh, based on what's happening right now between Ukraine and Russia. So if you are searching for war, that means any web page that talks about war, Ukraine or Russia should come on the top, right? So you could have those kind of logic built into the your seed URL component to basically prioritize that and put on the front of the queue because that's more time sensitive and that needs to be processed first. And then HTML downloader is plain simple component. It basically makes a get request, get the entire HTML into the memory. And once you have the entire HTML, you need to, of course, but before you go there, you also need to resolve the DNS. Given the domain name, you want to get the IP address and you want to visit to that IP address to get the content. Yeah, so once we download, then we need to have a parse that content. So we got HTML. We take the HTML and we want to identify, looking into the HTML tag, identify all the links, all the images, all the JavaScripts, everything that page has. Uh, so let's say we want to store the images. We want to identify all the images on the website. We want to extract all the PDFs. We want to get those information also from the website. But if we are only caring about links, then we only care about links. So basically it depends what you want to do. You will do in the content parser component. And then we need to worry about that the content scene. Basically, we don't want to process the same information again and again, right? As per some statistics, 29% of the web page have duplicate contents, right? So basically, content scene kind of eliminates the redundancy and reduces the processing time because you've already identified that. Now there are different ways to do it. So let's say I said the page size is 500 kilobyte. Now if you have like let's say 1 billion page, and if you have to go and compare each of those 1 billion pages, it's very inefficient, right? So one way is to do is basically you convert these page, get the hash code and put into the hash. And there's something called Bloom filters, which I will not talk more in detail in this particular session. Basically, you could use Bloom filter to figure it out if the page already exists or not in your database or contents. Next thing is the storage. So definitely we have to store your data somewhere, whether it's image, links, or any kind of files. We want to keep track of that. This is kind of very good overview, a brief overview of the URL extractor. So what's happening here on the left? You see you're basically you loaded the entire web page into the memory, and using that web page, you extracted all these links. So let's say you just care about these links. So you got all these links, and you can put this link into the queue to be processed, right? And you also want to use the URL scene to ensure that you are not doing a duplicate processing. Okay, this is the overview of the process. So initially you have the seed URL. The seed URL gets entered, the URL frontier, basically it's a queue. The queue decides which one to execute next. The HTML downloader basically fetches the item from the top of the queue, resolves the DNS, goes to the website. Sorry, first DNS gets resolved, then you download the HTML, then you parse the content. You look at the content scene. If it is a new content, you will put into the content storage. You extract the link, and then you create a URL filter. And then if you have already seen the URL, you don't know to process that. And then all the new URL that you have fetched that you haven't seen before, it goes back and gets added to the queue. So basically this continues till you are done with all the URL in that particular seed URLs. Okay, so now we'll look at the very high level diagram of this the, um, the process. So this is basically a crawl architecture. It's very simple. So you can see same diagram but represented differently. From the website, you get the DNS, you get the IP address, go and fetch the content from the web page, parse the content, check if the content you have already seen the content. Then you also need to look at the robots.txt, and you want to ensure that all the URL that you are seeing is included, is allowed in the robots.txt. Then only you want to process that. Then you want to eliminate your duplicate URLs that you have already seen, and anything new you go back and add to the queue again, and then parsing. So basically these loops continue till you are done, right? So we got like a basic outline of the architecture. We understand all the components that is needed for the crawler. Next step is to do a design deep dive. Here, as I said, we need to look at there are two different processes: DFS, BFS. Then we have a URL frontier, HTML downloader. We need to ensure robustness, okay, extensibility, and we want to detect and avoid any problematic content. So this is kind of an example of robots.txt. As you can see, we have a user agent. We have disallow URL. That means it's saying robots not to go to these URLs, and these are the URL allowed. And also you could have a sitemap. So basically, if you go to www.microsoft.com/robots.txt, you might see some kind of sitemap.xml. So this one basically will contain all the URLs that is allowed to be visited by robots.txt. And you could also see something like that, like user agent ETO spider disallow. What is saying is this website doesn't welcome this spider. So this is like one of the common spider uh, basically across the website. So you could allow or disallow any spider that you don't want. So by default, everything is allowed unless you have a disallow list. So this spider is not allowed to visit any of these pages in this particular website because it's a root folder. Okay, uh, this is a different representation of this the architecture. So as you can see, we have a component called prioritizer. This is basically a priority queue. So once it gets prioritized, imagine you have like a multiple workers. It basically once it gets prioritized, goes to the queue, and then we have a front queue selector and the back queue selector. So basically URL from top to bottom, and front queue, there are two queues. Front queue manages the message priority, and then back queue manages the politeness. That means if you want to see how many times you can hit a particular website. For example, Microsoft would say spider is allowed only once a day or something like that, right? So so you have two different queues. One is for priority of the URLs that you want to visit, and then a back queue basically how often you want to visit. And then if you think like this, right? So if you are making a crawler only for your company website, it's fine. But if you are making a crawler that's huge, the requirement is to visit 1 billion web pages in a month, right? So you cannot do on one machine, right? So you have to distribute the load. So basically, all of the steps that we have seen, all those different 7 components, we could distribute. We want to make sure that our crawler is polite, and from the design perspective, we can have like a multiple crawl thread under the different machines, and think about having a geographically distributed nodes because it makes more sense to have the crawler sitting in the region where you want to crawl, right? So imagine you have a crawler sitting in US, and you're trying to hit a web page that is hosted in Philippines, right? It's too much. So basically, it's better to have your crawler distributed across geography, and it kind of targets a local geographical area for that crawler. This is basically again same diagram. The only thing is we have the host splitter. So once we have the URL filter, you could basically distribute it to different hosts to go and process. And all of these hosts will go to do the exact same thing what you see here. and it's going to put into the duplicate URL eliminator, and then whatever is once the duplicate has been removed, it will go back to the URL frontier. And then let's look at the spider trap. So spider trap is something like there are some website, it has so much nesting or so many URLs within itself that it's difficult for the spider to come out. So once you start get in and you find links, you click on the link, then you go to another link and the link gets generated forever. And one of the scenarios, for example, let's say e-commerce website, right? For example, let's say you are visiting Nordstrom.com, right? And Nordstrom.com has, let's say, 10 product types, 7 brands, 6 colors, different price range, different way of sorting. And each time when you click on something and you see a different, the URL got changed. Now, just by one product and so many small combination, you can think you have created more than 34 billion links, right? That's huge. So you want to avoid these kind of things. And the way to avoid is basically what you want to do is you want to set up a crawl time. Anytime you visit a web page, you set up a crawl time that I should be out within, let's say, 5 minutes or 10 minutes out of this page. So let's say if you're unable to come out, let's say you're still there and you're not out, that means the timeout happened. You want to capture all the URLs that you have visited, and you want to identify the pattern. That okay, what is the pattern? What is different? Maybe the URL is exactly same, but only the item number is changing, or maybe they have a color, they have a URL called color that's changing from black to blue to green, right? So you have found the pattern. You want to avoid these pattern from crawling next time. So you can say, okay, do not, if you see this URL, don't visit, right? And from the okay, so we are done. We are kind of talked about a couple of things: Bloom filter, BFS, DFS, hashing, multi-threading, and how DNS works. So I would highly suggest go and read more about these, right? Uh, to understand the crawling part, and also Bloom filter is very useful for other different kind of search mechanism, which we'll discuss in different session. So now if we just look at the high level, what kind of architecture we are looking for. So you can think of, you can have like a worker running on EC2 instance, or it could be an AWS Lambda. And you could use any SQL storage. It could be RDS, PostgreSQL to store the metadata. And you might want to use S3 bucket to store all the images and PDFs that you have downloaded. And then you need to maintain the list of URLs to be crawled, and also the list of URL that you have seen, right? And then you have a worker, you should have a worker URL worker thread that can like poll the database and identify what to do next. And then each URL should have a status and date when last crawled and the timeout, right? So that way, whenever you want to crawl a website, you want to see when was the last time you have crawled. Is the timeout already happened? If not, then you don't want to crawl again. So you want to be polite. You don't want to be keep on crawling same website every time whenever the worker thread wakes up, right? You want to make sure to crawl only those pages that hasn't been crawled for a while or the timeout has expired, right? Okay, guys. So with this, I'm ending this session here. Thank you very much. Goodbye.